Finally, at part 3 of module 3, we're going to look at the analysis and output, putting together everything you've done so far and checking out the fruits of your labor. So we've set up the elements, we've set up the points, the supports, the loads, and finally the cross sections. So first step for analysis, assemble the model, and then we're going to analyze that model. Connect those two. And then before I go further, I'm going to put in all the inputs. So pulling in elements and connecting it to element. Don't forget to hold shift so that for multiple inputs they can all go in without knocking the other ones out. Holding shift, and you'll see that the plus sign shows up near your cursor, implying that you're doing it right. And then choosing points from the remove duplicate points and putting that into points, supports into support, mesh load into load. One quick thing, you want to make sure the orientation is global and not local to mesh, or it'll end up looking wrong. It just means that the XYZ matches the global XYZ in Rhino. And then finally cross sections, and because there's 4 of them, you got to hold shift when you put in the other 3. And now we can play around with some variability. Holding shift on the keyboard, and then model view, so we can see what is happening. Model into model, so you can see this crazy deformation happening. I'm just going to reduce the scale, and then beam view. I'm going to set it so that it shows us axial stress. And then finally the legend, so we can see the colors. So match legend colors and legend tags. And this will tell you roughly what the stress colors mean in numbers. And I'm going to pull out panel, / So there's a huge displacement of 2.1 meters. So your task is going to be to find the correct cross-section combinations from these 4 so that that doesn't happen. And remember, a European section, HEA 100, is not very large, so you can play around and choose things that are bigger and that make more sense. And finally, as I was mentioning, the mesh load, if I were to change the number slider, this is just in case you're curious, to 100. And I'm going to pull the deformation, which is sort of the final result of this. If I increase the number slider, it stays roughly around the same, and what's happening is it's reaching higher resolution and being a little bit more accurate the more you put in. But of course it takes longer. So it's up to you if you want to increase the mesh size. Just trying to keep it above 10. Otherwise 10 is fine. And as a reward for making it this far, here's a smiling baby seal. Thanks and good luck.